Just want to do a quick introduction on AI Camp. We are a global online platform for developers, engineers, and data scientists to learn and practice AI technology, with the mission of make AI available to all developers. AI Camp have grown to over 50,000 tech engineers in the group, have hosted over 300 local tech meetups, workshops, boot camps, large tech conferences, and live stream most of the tech talks globally. We have local study groups in major cities in the US, a few cities in Europe, India, China, Australia. You can take a look at the website to see our upcoming tech talks, workshops, and crash courses that we offer. We are excited to have Giorgio from Amazon today. So in today's talk, you will learn how to define, build, train, deploy a machine learning model on the Amazon SageMaker infrastructure, how to feed the model with the data that come from a user's social media accounts, and how to consume the SageMaker endpoint and display the food recommendation in the Android app. So without further ado, let's welcome Giorgio.
Thank you very much for the introduction. And it's a pleasure for me to be here today. It's a lot of, we have a lot of things to discuss. I hope that everybody can hear me okay. And I'll start sharing my screen.
Okay.
Here we go. Can everybody take a look? Can everybody see my screen?
Yes.
Okay. Cool. So, yeah, the focus for today is try to understand how we can combine several pieces of software together to take advantage of existing infrastructures and existing algorithms to create a different experience. Basically, which is the experience that we want to create? We want to help our users. Which users? The users of our potential and ideal app. Everybody loves food, I guess, and that's basically what we're trying to solve. We want to give to people an opportunity to find and discover food around them according to their food preferences. The layers that are involved in this talk, and actually behind the scene there is a prototype that will be unveiled by the end of the year on GitHub as an open source project. The layers are an Android app, the usage of APIs that come from Twitter, Facebook, and the major social media, Firebase to manage the authentication of the user, SageMaker, AWS Lambda, and AWS API Gateway to create a consumable web service that is fed and powered by machine learning algorithm. TensorFlow Lite, because we want the capability to have our model running also on a mobile device. And last but not least, of course, we have in this scenario also Android as an operating system. Wait a second, we are talking about distribution. What is the distribution? Well, that's a good question. And if you're wondering what it is, the services are fully distributed and the mobile devices are getting a representation of your model with TensorFlow Lite that will help you and help the user to get faster predictions in real time. And this is distributed completely. So, are you getting ready for that? I hope so. The ingredients. Given that we are talking about food, I think that we should start with the ingredients that we need to build and to discuss this implementation. We need images, user-generated images, and any image that created any user engagement. Basically, whatever a user can like or a user can potentially like will be a very key part of the data that we're feeding to our algorithm to determine the food preferences. Images recognition. We need to recognize images in which scenarios. We have to cover 2 scenarios. If I'm taking a picture from my mobile device, I want to understand, I want to have an understanding if the picture is representing food or not. And if it's not on the device, and I'm accessing the feed of the users on social media, I want to be able to understand as well if these images is containing food or not. So we have basically 2 use cases. One is fully distributed because it's on the mobile device, and another one it's not distributed because basically once the image is on the social media, we can feed it to our algorithm. Food preferences model. This is nothing new. There are Food AI and several other companies that are open or closed source food models, food preferences model. There are several that you can use. Whatever is fine for these non-production ready experiment. And API wise, you have to start think a little bit about which are the social media platforms that you want to support. In this example, we'll focus on the Twitter API, but this doesn't prevent us to use Instagram, to use Facebook, to use other social media. Okay, let's see what we can do. Social media. Well, I imagine that each of us, in one way or another, have a social media account. It depends on your preferences, but most of the time, I found in my life that engineers has at least one Twitter account. And that's a very good place where we can start to gather some data. Because we can gather the data from the social media feed and from the mobile device as well. Mixing these 2 parts, we get a lot of information about our users. And basically, when we keep the model on the device, we're also keeping very safe the privacy of our user. Whatever it's online, it's already publicly shared, so we're not violating any privacy. And I don't think that any user can be feel offended or uncomfortable about us having him authorizing an app to look at his social media data. Firebase. Why we need Firebase? So, and what it is Firebase? Basically, Firebase is a backend as a service solution. It was acquired by Google, if I remember correctly, back in end of 2016, beginning of 2017, and expose several features such real-time database, user authentication, and more recently started to be a suite of products. So products like digits that allow authentication through a digital code, or Crashlytics and others are all under the Firebase umbrella right now. Why we're interested in Firebase? We don't want to, at least in this phase, we're not talking about saving any data or recovering any data, but we want the user to authenticate. We want the user to authenticate through his social media favorite account, and we don't want to implement all of this. So the Firebase authentication is a service that provides a facade to authenticate the user. It includes a remote API and SDKs that cover several platforms to allow the user to authenticate. On top of this, we can also completely manage the session of the user. We can understand when the user opens again the app, if it is already authenticated or not. And we obviously can handle the logout programmatically or accordingly to the user interaction. The platforms that are covered by Firebase are web, Android, and iOS. There are also experiments and SDKs to run the Firebase API, the client-side API, on Raspberry Pi or another embedded device, and it can kind of work. Basically, through Firebase, you can authenticate through your Google account, your Facebook account, your Twitter account, your GitHub account, or you can implement a custom authentication. The interesting thing is that from a user experience perspective, the flow is the same, the information required are the same. The only thing that changes is the disclaimer accordingly to each platform, which data the app can access. The Android integration, it's simple as updating a build.gradle file. Basically, you add the Firebase authentication package and the Play services. You apply the plugin Google Play Services, and your app is ready to integrate an authentication service that also includes a full UI. The initialization, it's in the case of Twitter, requires two information. Require a consumer key and a consumer secret. These information are information that you can get as soon as you register a new app on Twitter. Twitter provides apps in order to allow you or other developers to define how to access to the API of Twitter and how to access to data from your user account and other user account. Let me talk a little bit more about this. So the Twitter API are kind of a manifest that design and describe how an application should access to this data. You can integrate almost any API that Twitter provide, and the interesting thing is that you can get a lot of public data. A Twitter app is nothing more than this permission definition, and it's a security gateway that defines the authentication mechanism of a client. Basically, this is what you should see when you create a new Twitter app. Organization website, but the important thing are the application settings. The access level is read and write. It means that in this case, the application can also tweet and post for the user. That's the default settings that come with the app. I strongly encourage you to disable the writing, of course. You have a consumer key API, that is what we saw a few minutes ago in the previous slide, and a callback URL. I want to focus your attention on this callback URL. Whenever you want to implement a solution that is based on Android or iOS, the callback URL, that is what get called by the SDK after the user gets authenticated, must be Twitter SDK : // Nothing else will work, and you will get weird errors. To access the feed of a user, once you created your Twitter app and you integrated the SDK, when you created the Twitter app and integrated the SDK, it's simple as writing this line of code. This is Kotlin. For people that is not familiar with Kotlin, it is a very interesting language baked by JetBrains that is the same company that build IntelliJ, Android Studio, Sea Lion, and a bunch of interesting tools. They also have good support for Python. And it's starting to be the de facto standard in Android development. It's much more concise than Java, and it's also less error prone. But this is probably the topic for a different discussion. So with this simple function, you access all the images of a user. Why this happen? If you look at the code, there is a user ID that is the Twitter handle of the currently authenticated user. The Boolean value include entities. It's saying to the Twitter API, please go and capture also all the medias, surveys, and all the information that you want. The tweet mode extended, it's exactly what you need. You will access the media. And then once you get the feed, you can filter by extension and understand what is an image and what is not an image. So let's take a look to this thing in action. Here we go. Oops, sorry. Here we go. So let me launch the emulator. And we'll take a look to the flow, and we'll see what is behind the scene, what is happening behind the scene. It's Gradle, it's building. For people that is not familiar with Android. It takes a little bit to compile an application. There are slower things, but there are also faster things around the world than compiling an Android app. But hopefully, everything will work just fine. Okay. Here we go. It's installing the APK on the device, on the emulated device. You should still see pretty clearly what is happening. So basically, and I can drive you also step by step in the app. What is happening is that we're getting all the data that we need in this simple call. If we let our debugger go, we should see that, oh, fantastic. That's why we shouldn't do a demo like this. It crashed. Okay, I'm sorry about that. So basically, what I'm trying to show you is these request that is calling the 1.1 statuses user timeline JSON API and returning everything back. I do apologize for this crash. I will move back on the slide to avoid to lose time. Okay, so now we have a list of images, and we need to do something with this image. We have to classify this image, and we need to understand which can be marked as food images. How we can do this? So we need for sure a model, and we need an algorithm. This algorithm should really be exposed and easily to access. So we can think about using SageMaker. Amazon SageMaker is a fully managed machine learning service that allows you to build and train any machine learning model. The interesting thing is that you have a Jupyter notebook that is fully integrated, and it's also very interesting the fact that Amazon SageMaker comes by default with about 50 different 50 or 60 different algorithms, from image classification to medical algorithms and much more. If you want to create a custom image classification, you can, because you just need to prepare your data set and start training the model. SageMaker keep all the dataset in an S3 bucket. An S3 bucket is nothing more than a distributed storage that Amazon services can access between each other, and that also you can use, you can access, an app can access, according to how you configure it. One model that we can use to start is the Food 101. It's a good starting point, has enough information and enough data, and provide usually great results. One interesting thing about SageMaker is that SageMaker supports transfer learning. Basically, it means that we want to reduce the time that is required to training a new model, given that SageMaker has all the cloud-based services, a pay-per-usage billing model. And to reduce the cost of our implementation, of our training, we want to train the model offline, pre-train the model offline, and then upload the pre-trained model. The built-in image classification algorithm that SageMaker exposes, it's already prepared for transfer learning. So you basically want to download the dataset, and you want to unpack the images and convert all the images to JPEG grayscale, 28 by 28 pixels. And you want to create two different LST file using record.io. One file basically is for the training portion of the dataset, and the other one is for testing. And then you generate the rec and the LST, and you are ready to start. Ready to start? What it means? It means that we are copying these files to the Amazon S3 bucket, and this bucket will be accessed through SageMaker, and you will have the opportunity to see the training also happening online. Obviously, you need to use hyperparameters, and the hyperparameters that are exposed by the image recognition algorithm of embedded in SageMaker are a lot. We'll go in the main ones only. We'll cover only the main ones. The number of layers can be absolutely configured. The image shape, you can also determine the number, specify the number of classes that the model can classify, and the epochs. With the epochs, you can clearly say to the model how many times the training algorithm will pass through the entire data set. It's not directly proportional that more epochs give you better results. So give a try with a low number, and then if you see that you're not getting very good approximation, tweak a little bit your hyperparameters. But remember that the epochs is not the only one that you should tweak. To train the model, basically, SageMaker uses a Docker container that is previously configured with all the libraries, frameworks, and binaries that are needed. That's very scalable, and these also allow you to create a Docker image in your own local machine, and then expose this Docker container to your SageMaker instance. And you can have your own custom algorithm. So you can easily work online or offline according to your preference. And online, you can monitor the training, and you can understand which is the CPU utilization, how many GPU has been utilized, and so on. Another interesting feature of SageMaker is that you can pause the instance when the training is done. So if you, end of the day, you are happy with your local results, you upload your new Docker image, you run the training, you go to sleep. You're not paying an extra cent for this. Once you have your model, your algorithm up and running in the clouds, you need to expose, and well, actually, you need to consume this information. You can do this through AWS Lambda. Basically, AWS Lambda run some code for you, removing from you the pain of managing a server. The name, it's pretty self-explanatory. Most of the time, you're simply creating and defining functions that, given an input, return you an output. What is interesting is that these Lambda can be called directly from any web or mobile app, basically from any client that has access to it. To create a function, you don't do anything special. You create a function name. You specify the runtime that you want to use. In this case, it's Python because we are dealing with some machine learning algorithm written in Python, but you can also use Node.js and other programming languages. You choose a role that give access and expose your function, and you're ready. Once your Lambda is configured, can consume the data from the machine learning algorithm, but is not yet exposed to the internet. To expose it to the internet, you have to configure the API gateway. The API gateway is another service that is part of Amazon Cloud that allow you to publish, maintain, and monitor any API at any scale, because you can really get whatever workload is needed. You pay on demand, so you pay on the go. It's up to you. The API gateway provides the tools to determine who can access an API, and also which API operations are available. These allow you to create an architecture of complex APIs. Some of them can be exposed internally in between different lambdas that are doing whatever complicated algorithm or whatever complicated computation that you want. and some can be exposed to the external. You create a new API with a simple name, you determine which is your endpoint type, and you will be able to also configure your API according to the regions. And once you've done this, you specify which is the integration type that you want. You can expose an entire service, you can expose a mock, you can expose a Lambda function, and once you have done that, you can specify the URL parameters, the HTTP headers, and how to map the body of the response and of request of your REST call. Basically, you need 3 simple steps to expose your algorithm. You convert the output of your model in such a way that you can expose it through SageMaker. And that's the training part and the slide that we covered where I described how to manipulate the data set. You create an endpoint configuration and you deploy the model using the endpoint configuration. And once you've done that, you are basically creating this architecture. You have a client that through the Amazon API gateway is calling your Lambda that is consuming your trained model that is living in SageMaker. I would emphasize that it's not just a web browser. Anything can access this. Anything that supports JSON, basically everything. Every screen, every surface, tablets, also embedded devices like Arduino, like Raspberry Pi, Onion, all these things. Even better, to really take a look to what you can, the scalability that you can reach, is that you can have multiple models that are all Docker containers that get exposed through the SageMaker endpoint to the Lambda functions. And the Lambda functions are protected through the API gateway and exposed as HTTP endpoint. Okay, that was a lot about SageMaker, AWS, and the API gateway. Any question about this part?
I think there's some questions in the chat window.
Okay, let me see if. Okay, let me see how my Linux machine will react to this. Okay, it's Q&A, right?
Oh no, it's in the more.
Okay, sorry about that. And thanks for your help. Okay. Oops. There we go. More.
Then the chart, yeah.
Thank you. Okay, let's start from the very beginning of the questions. Can user import existing IPython files into SageMaker? Yes. Which models are already pre-configured in SageMaker? A lot. There is a huge list of 60. Are these costs associated with transferring these models to a dataset in S3? No, the costs are associated to the usage of SageMaker and the usage of the instance that you configure to compute your model. There is a separate billing that is S3, and S3 is basically billed accordingly to the usage of data that implies. Can SageMaker connect to our data warehouse instead of copying the data into the S3 bucket? Sorry, forgot. Okay, no worries. I never tried that. I don't want to say no, but I don't know if it's the best architecture, because the point of SageMaker is to operate behind the protection that the Amazon AWS services provide to you. When we start to connect to your data warehouse, we are actually exposing a lot of information to potential hackers. But I think it's possible. I don't know if it's the best approach. Next question, are the Docker images exportable to test or extend locally? Yes, they are. Firebase offer CoreML integration support or plan to? Well, I think that there will be some announcement in the next days, but I'm not sure about CoreML. Why use Lambda between SageMaker and API Gateway? Can API Gateway connect directly to PageMaker? No. API Gateway, it's the way you design your API, then your API must consume something. This something is usually a Lambda and not directly a SageMaker model. Why did you choose 70% for training and 30% to test set? Well, basically, that was an approximation that I read on a paper that was released a few years ago about food recognition algorithms, and I started with that. I'm getting decent results, so I probably will change it, not right now. Can SageMaker connect to other repository to import code from there directly? No, not that I know. Why did you choose? Okay, I answered to the 70% and 30% test set. Any other question, or can I go ahead?
I think you can go ahead.
Cool. Okay, so what's next? We need to recognize these images. So we have the infrastructure on AWS that is now able to expose our algorithm, and we can design our API in such a way to get a very easy answer. But we want to do also something more. We want to recognize these images on our local device. Why? Well, because low latency and having an immediate fast answer for a user, it's mandatory. So every time that a mobile app is taking time to give an answer to the user gets frustrated and interpret this as a poor user experience. So we want our model to run also local. How we can do this? We can do it with TensorFlow Lite. TensorFlow, I think everybody is familiar now, but TensorFlow Lite, it's a very lightweight version of TensorFlow that is fully designed and architected for mobile. It's easy to distribute because of its nature. It's fully written in C++, and it's one of the kind of cross-platform development that work C++. It's such a low level that usually you don't have so much pain moving from iOS to Android and other platforms. It's optimized for mobile, and this means that the computation will not draw out your battery, will keep the device responsive, and so on. It's portable because you can decide whatever model to use, whatever model you want, but there are several open source models that are available on the TensorFlow Lite documentation, such as Inception, B3, and MobiNet, and you can retrain these models with a custom dataset and even build your own custom model. The interesting thing is how you distribute this model. So one strategy is to embed the model into your app. That's potentially creating a big APK. Android support on-demand features that you can download after the user touch or access specific part of your app. So I would recommend to distribute it on demand as a feature. And about the update, that's a very huge topic. We can have a separate session how to update models on a device at runtime. But let's get back in business. So MobileNet, it's a family of mobile-first vision models, and TensorFlow, it's designed to maximize, TensorFlow Lite, it's designed to maximize the accuracy the information that can get from these models. Again, are very small, low latency, low power models, parameterized in such a way that you can meet the resource constraints for of a mobile device. Don't forget that despite mobile devices are much more powerful, it's still a completely different kind of power compared to a desktop or to other machines. Trainable. These models are all pre-trained, but again, you can retrain the model and distribute a retrained model just in case it doesn't meet your expectations. The Android support, it's pretty well designed. As I said, it's a C++ library, TensorFlow Lite. So basically you use the Java native interface, the JNI, to access whatever API you want. It's a bit of overhead. There are not significant performance trade-off until you don't pass huge amount of data through the JNI. And given that you usually don't want to do that, and you usually don't do this because you have these data that are local on the device, so you don't have to pass the entire data, but eventually reference to the data. The tests that I've done so far are pretty good. You can load graph, set up inputs, and run the model to calculate outputs, and through these JNI APIs. Other platforms, TensorFlow Lite runs on Raspberry Pi, iOS, and other embedded devices. Why I'm mentioning this? I'm mentioning this because if you want to experiment also on different platforms, you don't have to reinvent the wheel, or you don't have to train the model or repeat several tedious and time-consuming operations. You can simply just use it. Let me show you. Hopefully this will not crash. Usually I get better result with demo. Let's see. This is a very simple app. It's recognizing whatever object. It's based on one of the last releases of TensorFlow Lite that is pretty recent, a couple of weeks, maybe 2 or 3 weeks ago. And that's a nice demo to see. Okay. So, okay. The model recognizes the candle. The model is recognizing a studio couch. The model is recognizing now a bathtub. Wow, what is, oh yes. That's debatable. That's not a bathtub. But it's recognizing now other object inside it. And basically this is the performance that you can expect. So it's absolutely lightweight, and the emulated device here, it's a Pixel 2, but the performance that you usually get on an emulated device are significantly lower, but the speed, the recognition speed, it's good enough. And yeah, and we got a microwave somewhere, so we're good. Now we have a wardrobe that has been seen. And that's it. Let's go back to the slides. So, wrap up. What we discussed. We discussed how to get the feed of user social media accounts. We need a Twitter app, a Facebook app, GitHub app, whatever social media you need. Through the app on the social media platform, you define your access policy. Through Firebase, we can use the same facade to access each of these information, and we can pick whatever we need, filtering the information that are posted in the feed of any user. We know how to define, how to get and where to get a model to predict food preferences. I mentioned the food 101. It's the best starting point. It's what I'm using. I'm very happy about it. We know how to deploy a custom machine learning algorithm on a distributed service, because using SageMaker, we can deploy our Docker container, and again, we can expose everything in a secure way through AWS Lambda and AWS API Gateway. And we know how to start recognizing images on mobile devices, because we can base our solution and assumptions on TensorFlow Lite. Resources, and I will send the slides immediately after these webinars, so you will have all the links that you may need. The resources that you should take a look to start playing with these kind of architectures are the Android Firebase authentication, the Twitter API, how to create a SageMaker endpoint on AWS, how to get started with TensorFlow Lite. I strongly recommend, if you're not familiar with machine learning, to read the article, What is a Neural Network? And there is another interesting article that is on medium.com that give an overview of the 10 most common training algorithms. I think it's useful to understand what you're doing rather than just guessing. It gives you the opportunity to do educated guesses. And one last thing is that all these projects that I'm working on, my plan is to release it open source by the end of the year. Worst case scenario,